Hello guys, this is the Sky Academy. Yes, now we are going to look upon the chemistry. Yes, chemistry. Yes, senior 4 chemistry. This is a guide to learning chemistry senior 4. Yes, by jumping quickly, let us go through the contents. Yes, we are going to go through the contents. Yes. Okay. Here we have the content. See, there is a term one content. Here we have the unit one, which is called structure of an atom and the mass spectrum. This unit number one is the one we are going to start with. Yes, but we will continue moving through as the time allows us. But we are going to start with this unit. It is the first unit of the senior 4 chemistry for Rwandan schools. Yes, simply let's dive quickly into the content itself. This is the unit 1. It is called the structure of an atom and the mass spectrum. The structure of an atom. Yes, but before diving into the content itself, we need to first know what chemistry is. Yes, those senior 4 students, even though they have learned the chemistry from 3 years back, but some don't even know what is chemistry, what it deals with, because they have learned it in senior 1, where they were even not entering in the content itself. Yes, but here we wanted to define clearly what is chemistry, so that we continue to build on the atoms, the element, the compound, the structure of an atom, and all those kind of chemistry that is going to follow. So, chemistry is defined as a branch of science that deals with the composition and constitution of substances and the changes that they undergo as a consequence of alteration in the constitution of their molecules. Here we find two concepts which are new. We see substance, we see also molecules. Here, this is a branch of science which deal with the composition, the constitution of substance. Yes, when you say substance is anything there, you can say it is a substance, because um, we look upon the composition of substance. But also not only the composition of substance, but the changes that may occur when we alter those composition, when we change some different conditions. In chemistry we can change the temperature, we can change the pressure, also. Yes, those are the conditions that can be altered from the substance composition. Yes, all those things are learned through the subject chemistry. Yes, here chemistry also can be simplified as the study of composition, structure, and properties of substance under different conditions. This is a more clear definition. Chemistry can be defined as a study of composition, structure, and properties. Composition, structure, and properties of substances under different conditions. Yes, this is a simplified definition of chemistry. Yes, but when we come to composition, that's where comes we look on the substance, and then what made those substance? What made those substance? Yes, yes. For example, I can take away maybe a stone. I can take a given material, anything. But any material is made of different things. Yes, those are things which constitute that substance. That's where chemistry is going to lie. But also, it is not merely going to look upon what made the substance. but also to make to see their structure. Yes, their structure, their shapes, their, yes, how they look like. Yes, but also the properties, their behavior, the chemical behavior of substances under different condition. For example, I can take a given plastic. If I apply heat, that plastic will change the shape. Even the molecule that made it can change. Yes, we have different structure of substance, like solids, like liquid, like gases. But if it is solid and then we apply heat, maybe the solid can be changed into liquid. Those are the changes, the different conditions that can be changed from the substance. Here, in fact, chemistry look upon the inanimate matter. Yes, the inanimate matter, as opposed to biology, which look upon the living things. Chemistry look upon non-living things. Yes, their composition, their structure, and their properties. Yes, let's look upon the definition of a substance. But not only the substance, we are going to look at different concepts here, to dive into deep into different concepts so that you can enter easily in our concept, or in our session of today. Here, the substance is a physical matter or any material. A physical matter, something that is tangible, you can see, you can touch. Yes, yes, it or a material. Different objects, different things, they are substances. All substances that are found in nature are made up of matter. In fact, substances that we see in nature are made of matter. So we need to know what is a matter. Matter is anything that occupies volume and which has mass. Yes, we have seen that matter is anything that occupies volume and has mass, and then all substances are made of matter. Okay, then let us look upon the molecule. A molecule, this is a group of atoms joined or bonded together, representing the smallest fundamental unit of a chemical compound that can take part in a chemical reaction. A molecule is a group of atoms joined together or linked together by chemical bonds. Yes, but those atoms represent the smallest fundamental unit. Smallest fundamental unit, this is a molecule. For example, you can take oxygen molecule. Yes, this molecule of oxygen is made up of two atoms of the same element. Two atoms of the same element, oxygen. Here we have 5 atoms of different elements. Here we have carbon. Here we have hydrogen. We have four hydrogen. Yes, but they are bonded in smallest fundamental ratio. Here we have 1 carbon and 4 hydrogen. This is a methane, and this is the molecule of oxygen. Yes, those examples are examples of a molecule. Then you can look upon a compound. Here, a compound is a substance which is formed by 2 or more different types of elements which are united chemically in a fixed proportion. A compound is formed by 2 or more different types of elements which are united chemically in the fixed proportion. Here, a compound, for example, here you can have a water molecule or methane also. For here, we need to have different type of element. We can have 2 or more. We can have 2 or more different type of elements. That's where it comes. Whereas here, it is a group of atoms joined together. Maybe you can have atoms of oxygen, but different atoms. But here we need to have more different type of elements. That's why you have water molecule, which is a compound, methane also, which is a compound. In fact, here, some may confuse molecule from compound, but they are different. All molecules are not compounds. That's what we can take from here. All molecules are not compounds. In fact, we have some molecules which are a compound, like for example methane. But for example, this oxygen is not a compound because it is made of only the atoms which are bonded to smallest fundamental unity. But here we have seen that a compound has two or more different type of elements. You can understand here. Okay, let's continue. Here there is a question that anyone can ask him or herself. Why we have looked first on the definition of chemistry? Why are we looking at the definition of chemistry firstly? The answer also can be proposed. In unit number 1 of senior 4 chemistry student book for Rwandan schools, we are going to look upon the structure of an atom. Yes, we are going to look upon the structure of an atom. And to know more about it, we were to know first the meaning of chemistry, which deals with the matter, whereby if we finally divide the matter, we reach to the smallest particle called the atom. In fact, atom is fundamental, is a basic unity that we need to learn in order to understand chemistry. For biology, the starting unit is what you call a cell. A cell which can be united together to form tissue which can be united together to form yes, we have a cell, we have a tissue, we have organ, we have organ system, we have a system, then we have organism. That is organizational structure, or yes, or the building block in biology. Whereas in chemistry, we first look on the atom, then the molecule, then the compound, then the matter, then we can find a substance, a given substance or any material. That's why we have first look on the definition of chemistry in order to understand what it deals with, and then we come back with the atom. Yes. So the structure of an atom, that is the topic of today, the structure of an atom. What we have passed through before was just like it was like an introduction, yes, but the content of today is the structure of an atom. So let us look upon the definition of some key terms. What is an atom, in fact? An atom is the smallest identifiable unit of an element. It is clear. It is the smallest identifiable unit of an element. That is the starting point when we build an element. Yes, means an element can have different atoms. Yes, what is an element then? An element is defined as a substance that cannot be broken down by ordinary chemical method in a simpler substance. In fact, an element has to retain its properties because it cannot be divided or it cannot be broken down by ordinary chemical method. This is an element. Then what is a compound? As we have seen, it is a matter or substance formed by the combination of two or more different elements in fixed ratios. Yes, those are the key terms. Yes, let us go to the structure of an atom. Atoms consist of an extremely small positively charged nucleus surrounded by a cloud of negatively charged electrons. As we have seen here, the atom is the smallest identifiable unit of an element, but in atom itself, yes, it has some. It also constitute. It is built upon some things. Yes, some matters. Here, atoms consist of an extremely small positively charged nucleus surrounded by a cloud of negatively charged electron. This is the structure of an atom. It consists of a nucleus, and out of the nucleus on the surrounding there is a negatively charged electrons. Although typically the nucleus is less than 1/10,000 the size of the atom, the nucleus contains more than 99.9% of the mass of the atom. To understand this, we are going to look upon this diagram or this figure. Yes, this sketch is showing the nucleus. The nucleus, you see those blue balls and the red balls. Yes, those are when they are united together form a nucleus. As on the surrounding there are whirling electrons which are moving around the nucleus. Then in this theory, they are telling us that 99.9% of the nucleus, yes, is the mass of the nucleus. In fact, atom consists of a nucleus which is much dense, even though it is very small. In fact, we have a small nucleus which possesses almost all mass of the atom, because the electrons around there has a smaller mass but with a bigger space, as it is seen on the figure here. Yes, we have seen that those outside is electrons, and electrons are moving on their orbits. We will look upon this later. Then electrons are moving on the orbits, as you see here. But in the nucleus, we have protons and neutrons. In fact, nucleus is formed of protons and electrons. Yes, no, sorry. The nucleus is formed of protons and neutrons. Protons has a positive charge, whereas neutron has no charge. It is neutral. It is neutral. The neutrons are those blue balls, represented by blue balls, and the protons are represented by red balls. Yes, whereas those pink balls are representing electrons which are whirling or which are moving around the nucleus, the dense nucleus. By this theory, the atom consists of dense nucleus which contain protons and neutrons. Protons are positively charged and neutrons are neutral. They don't have charge. Whirling about the nucleus are particles called the electrons, which are negatively charged. Yes, those around the nucleus are negatively charged. Those protons are positively charged. Neutrons are neutral. They don't have charge. Yes, let's continue. This is the structure of an atom. And then we can look upon subatomic particles and their properties. In fact, when we say subatomic particle, we are dealing with the protons, electrons, and neutrons. But those are not subatomic particles that are there. But those are the ones which are more important when we deal with the atoms. But in the next lessons or far, we shall look upon other subatomic particles. Yes, subatomic particles are those particles which constitute an atom. In fact, we have seen that atom, even though atom is small, but it consists of some subatomic particles. Yes, they are not limited to protons, electrons, or neutrons, but we are to deal with these three now. Yet, we have some others like positron, photons, mesons. Also, those are the subatomic particles which are not going to be discussed in this session. Yes, here we have particles, neutron, proton, and electrons, and they are, yes, their representation. Yes, we have absolute charge, we have relative charge, mass, and relative mass. Here neutron with n, symbol n, yes, its absolute charge is 0. We have seen that neutron doesn't have a charge. It doesn't have a charge, means it is 0, relative charge also 0. Then a mass. Yes, let's first look upon the charge, absolute charge and the relative charge. This is have to be memorized in order to know it, to recall it, because they are going to help us in solving different word problems. Protons with the P or P plus, it have a absolute charge of plus 1.6 times 10 power negative 19. This is a plus, and electron it is a negative 1.6 times 10 power negative 19. In fact, the absolute charge of proton is equal in magnitude, but different in charge. Here proton is plus, where electron is negative. The value are the same, 1.6 times 10 power negative 19 on both sides. Then for the relative charge, neutron is 0, proton is plus 1, and electron is negative 1. Those are the charge, which are relative charge. Then we can look upon the mass. By the mass, neutron has 1.675 times 10 power negative 27, whereas proton 1.6673 times 10 power negative 27. But electron has a very short mass with 9.11 times 10 power negative 31. Negative 31. It is very small. That's why protons and neutron have almost all the atoms mass. For the relative mass, here it is 1.0087 AMU, or atomic mass unity. Here we can also say it is 1, also here it is 1, but here it is 0.0005485 AMU. Yes, and then when we say AMU, this atomic mass unity, which one atomic mass unit is equal to 1.67 times 10 power negative 27. Okay, then the mass of an electron is very small compared with either proton or a neutron. Mass of electron is very small. That's what we can take here. The mass of electron is very small compared with the one of proton or a neutron. Then the charge on a proton is equal in magnitude but opposite in sign to the charge of an electron. I have seen the charge of proton or the charge of electron. Those are they are equal. They are equal in magnitude. Only the charge are different. One is positive, another is negative. So I can thank you for today's session. Maybe we shall meet next for the discovery of the subatomic particles. But now let's end up for here. I thank you for your attention. Yes, thank you for your attention.